How about we take a look at a nice easy one? Example. All P are R. You've seen this one before. All Q are R. Therefore, all P are Q. Now you notice this one doesn't break the negation rules. We have an affirmative here, zero negations in other words. We have no negations above. So this passes that particular rule. Our middle term is R. And in this case, the middle term is the predicate of two A statements. You'll remember that A statements only distribute the subject term. So this one right here is invalid. It's invalid by reason of the fallacy of undistributed middle. This one's guilty of what we call the fallacy of an undistributed middle term. Now, we might want to take a look at just one more. Let's say we've got no P or Q. All R are Q. Therefore, no R are P. Now this one is standard form. Its mood is EAE. And for those of you in the audience who have this in your memory banks, our middle term is the predicate of subject, of the major premise and the minor premise. So it's figure 2. It's EAE2. We could easily diagram this one. However, let's just talk about whether or not it passes the rules. We've got three terms, P, Q, and R. Each are used twice, but not in the same premise. Check. We've got a negation as the conclusion, and one of our premises is a negation. Check. So it passes the negation rules. So now we have to ask ourselves does the middle term distribute? And if we have distributed terms in the conclusion, do they distribute in their corresponding premises? Let's check out the middle term first. Now our middle term in this case is Q. Does Q distribute? Absolutely. It distributes in an E statement which distributes both subject and predicate. It doesn't distribute in the A statement, but remember it's got to distribute in one of the premises. Check. Distributed middle term. Now, look at our conclusion. Our conclusion is an E statement. So recall that E statements distribute subject and predicate. So both R has to distribute up here, and P has to distribute up here. Now R is the subject of an A statement, and that distributes. P down here, which is the predicate of an E statement, distributes. So it has to distribute in its corresponding premise. And behold, it's the subject of an E statement. It distributes. This EAE2 syllogism passes the rules. And we can show you, just for good measure, the Venn diagram, since we can. Alrighty. We have P, Q, and R. We'll label our sections like so we can communicate. We'll diagram the first premise, no P or Q. We'd be shading in 2 and 5. Because no P or Q means There's not going to be any P's in class Q, and vice versa. Not going to be any Q's in class P. Our second premise, all R are Q. Here's R. All R are also in Q. So we're going to be shading sections 4 and 7. Now the good news about these universal premises, you'll notice that we end up shading in a fair amount of geography, or real estate if you prefer. So there's good odds that we're going to be excluding a fair number of classes of things here. So has no RRP been diagrammed? Okay. If no RRP has been diagrammed, sections 4 and 5 ought to be shaded in. And guess what? It's shaded here. This one's valid by Venn diagram because no RRP has in fact been diagrammed. Thank you.